This is the simple illustration of steam engine. When water is heated, it gets evaporated and produces steam. Generated steam has 1500 times volume than the water used to produce steam. It can then be used to create kinetic energy. First commercially useful steam engine was constructed by Thomas Savery. James Watt improved upon it by using cylinder and valve system. Steam locomotives helped to bring about industrial revolution. Let us study the working of a steam engine in detail. This is the illustration of steam engine. This is the water container. This is the boiler. This is the place where water is actually heated to generate steam. These are the pipes through which water and steam passes. This is valve. This device controls the passage of water through the pipe. This engine has two valves. This one is inlet valve which controls passage of steam. This is outlet valve which controls passage of water through the pipe. Valves open in one direction, only to let in or to let out steam at appropriate stages. This is cylindrical shaped container and piston is attached to it. This is the crankshaft which has the ability to transfer the power to the piston generated in cylinder. Let's study how this steam engine actually works. Water is heated in the boiler. The generated steam passes through the pipe and reaches the cylinder which has piston attached to it. As I mentioned you before, steam occupies more volume than the water. This steam has very high pressure. It exerts pressure on the walls of the container in all the directions. As the steam expands in the cylinder, it pushes the piston forward. Crankshaft connected to the piston also moves. Crankshaft converts linear movement of the piston into circular motion. The wheel of the crankshaft makes half rotation during the expansion stroke. Steam expands and it pushes the piston forward and loses some of its kinetic energy. As a result, it condenses into water. The piston is then pushed back into the cylinder due to low pressure. Due to inertia of crankshaft, the wheel makes another half rotation and completes one cycle. This is exhaust stroke. The condensed water is expelled out and fresh steam is let in to repeat the process. Steam engines were used to design cars in earlier days. They were also used to run trains. But the use of steam engines for transport vehicles is outdated today because of their low efficiency. Now that we understood the working process of heat engine, let's discuss its limitations. For learning purpose, very basic illustration of steam engine is shown to you. In practical, steam engine is very complex and consists very complex and bulk structure. Steam is very heavy. It needs to carry lot of water in order to generate high kinetic energy which we can use to run vehicles. Steam engines are bulk and heavyweight and not suitable for small vehicles. The efficiency of steam engine is very low. In the process of converting heat energy to kinetic energy, lot of energy is lost. Lot of energy is lost to boiling water. It requires lot of energy to rise the temperature of water to generate steam. Heating water to produce steam takes time and the engine cannot start instantly. To keep the steam ready, the fuel should be burnt continuously even if the engine is at rest. The limitations of steam engine lead to the discovery of internal combustion engine. Rudolf Diesel and Nicholas were the two pioneers in this effort. Today, internal combustion engines are used in all transport vehicles, scooters, cars, buses, lorries, and trains. All these vehicles work using internal combustion engines. Depending upon the fuel used, internal combustion engines are of two types. They are petrol engine and diesel engine.